Alright, before watching this video, spend 30 minutes on 2021 BC5 and 2012 BC4 before watching this video. Got it? Alright, so let's start. We have y is equal to f of x be the particular solution of dy dx is equal to y times x ln of x. And we have some initial conditions. The first one being f of 1 is equal to 4, and then the other one being f double prime of 1 is equal to 4. Part A says write a second degree Taylor polynomial for f about x is equal to 1, and then we're going to use this to approximate f of 2. A lot of these FRQs is going to be a lot of approximating. We've done a lot of approximating using tangent lines, Euler's method, Riemann sums. This one's going to be another approximation. So you'll see, especially on 2012, you have the tangent line, you have that Riemann sum, you have Euler's, and then you have the second degree Taylor polynomial. But let's go back to part A. All right, so we want to write a second degree Taylor polynomial. We know that f of 1 is equal to 4. We don't know what f prime of 1 is. I'm going to figure that out. So this is going to be 4 times 1 ln of 1, which is going to be 0. And then it also tells us that f double prime of 1 is 4. Great. All right, so that's going to give me 4 plus 0x the 1, well, 0 x minus 1 to the 1 over 1 factorial, which eventually is going to be 0, but I like to do that just for consistency. Okay, 4x minus 1 squared over 2 factorial. And my second degree Taylor polynomial is going to be 4 plus 4 x minus 1 squared over 2 factorial. 4 divided by 2 is just 2, so I'm going to leave that as 2. I'm going to approximate f of 2. So f of 2 is going to be 4 plus 2, 2 minus 1 square. So 2 minus 1 is 1. 1 squared is just 1. So I have 4 plus 2, or 6. So that's my approximation. The first point is going to be the Taylor polynomial. The second point is going to be the approximation. All right, so we're going to use Euler's method starting at x is equal to 1 of 2 steps of equal size to approximate f of 2. So we kind of know the first part because this is 1, this is 4, and we said that the derivative was 0. So my equation of the tangent line is going to be y minus 4 is equal to 0, x minus 1. And if I'm going to plug in 3/2, this is just going to be 0. So now I have y is equal to 4 again. Now my dy dx is this lovely thing right here. So if I'm going to plug that in, I'm going to have 4 3/2 ln of 3/2. So then my equation of the tangent line is going to be y minus 4 is equal to 6 ln of 3/2 of x minus 3/2. Now the reason why I said 6 was because 4 times 3 is 12. 12 divided by 2 is 6. Can't just simplify that. All right, I'm going to approximate 2. So that's going to be 4 plus 6 ln 3/2 of 2 minus 3/2 is 1/2. And that can also be rewritten as 3 ln of 1/2 plus 4 if I were to move the 6 and the 1/2. Now, if you want to keep it nasty, aka not simplify this, then your approximation would look something like and I know how some of you guys don't also simplify this. I'm going to do that. If your approximation looks like this, that's fine because this is going to give you the same answer of whatever this thing is. All right, part C, you want to find the particular solution. So go ahead and do that by dividing by y and multiplying by dx. Take the integral, so you're going to get ln of absolute value of y is equal to the integral of x ln dx. X ln x dx. Hopefully you haven't forgotten about integration by parts because this is an integration by parts problem. Think about I latte or I late. In this case, u is going to be ln of x. du is 1 over x dx. dv is going to be x dx. And then v is going to be 1/2 x squared. So you have uv 1/2 ln of x. Let me rewrite this. 1/2 x squared ln of x minus the integral of 1/2 x dx. All right, I'm going to take the integral of this and simplify it. It's going to give me 1/4 x squared plus c. I'm going to plug in my initial condition now of 1 and 4. So now I have ln of 4 is equal to 1/2 1 squared ln of 1 minus 1/4 1 squared plus c. Well, ln of 1 is 0, so that just cancels out. So now I have ln of 4 is equal to negative 1/4 plus c, which means that c is ln of 4 plus 1/4. So now I have ln of y is equal to 1/2 x squared ln of x minus 1/4 x squared plus ln of 4 plus 1/4. And then you're going to e both sides because you have y with ln. So this is going to get pretty nasty, but this is your answer, I promise. So e to the 1/2 x squared ln of x minus 1/4 x squared plus ln of 4 plus 1/4. Don't try to simplify this, okay? I know usually sometimes I will tell you to simplify stuff, but this one, just keep it nasty and call it a day. The AP graders can read this and they'll be like, oh, that's okay. And then you'll get the full credit. How many points was that? I don't know. But obviously you could look at the scoring guidelines for 2021. I know that I said I was going to do 2012, but I think 2012 is more self-explanatory because you have the equation of the tangent line that we've done since forever. Midpoint, we've done that since forever. Euler's, we've done that since forever. And then the only new part is going to be part D with the Taylor polynomial. But I feel like this one was an easy lesson for you to understand and do in terms of this unit before it gets more complicated. All right. Unit 3, lesson 2 is going to be on power series. So look out for that video next.